All right. So I am recording this right now just in case Ian can't make it. It'll be found on my YouTube channel a little bit later if any of you guys want to watch it later. So I think we'll just get started. And if he shows up, he shows up. But if not, we want to make sure we get enough of this done. So how are you doing today?
Good.
All right, cool. Glad you're here. Glad you can make it. So let's just get into it. So we're doing this contest today. And I want to see if you could walk me through each of these problems, just because I'm kind of curious to see what strategies we use. Strategy is a big part of solving math problems, and sometimes it may not be really clear what we have to do. So let's start with number one. And I was hoping that you could just maybe talk me through this one. Pretty simple, but what strategy do we want to use?
I just used, I just, solved with it and then, yeah.
So what did you get?
64.
Perfect. Very nice. Now, what about number two? We're given it looks like they give us a pie chart showing us the results of a survey of people in East Carolina. I don't think that's a real place. I almost said East Carolina, like North Carolina or South Carolina, but East Carolinians, I guess, who do not use the internet. What is the percent of East Carolinians non-users for whom cost and time are not the primary barrier? So how do we want to set this one up?
Just like all the ones that aren't cost and time, just add those together, or you subtract cost and time from 100.
All right. Can you write it on the board? I think you have permission to annotate. Show me how you would set this up.
I'm on a Chromebook, so it doesn't let me annotate.
I think it is disabled. Here, let me try disabling it and then enabling it. So what do you see? Do you see any kind of meeting controls on your window at all?
No.
No? All right. So remind me, what did you say about this one? You said we wanted to set this up how exactly?
You could either subtract the cost and time from 100, which is the total thing, or we add the cost and time together and then subtract. Oh no, sorry, wait, no. Or you add everything that's not cost and time.
Hey! Hi guys!
Hey, yeah, glad you can make it.
Okay.
Wait, what question are we on?
So we're on number two. We already did one. We got an answer of 64 for number one. So now we're doing number two.
Oh, yeah, that's what I got too.
So I'm curious to see how you would approach this one, Ioni. Is it Ioni or just Ian?
Ian, but it's a nickname.
All right. Ian, I'll just go with Ian. It's what I'm familiar with. So Ian, how would you approach number two? What kind of a strategy do we want to use?
Well, I don't want to add everything. So it's where cost and time are not primary barrier. I just added the ones that cost and time were the barrier, and then subtracted that from 1 or 100% or 2 divided by 2, however you call it.
Excellent. So yeah, we want to identify the spaces where time and money are a concern. So that would be 13 and 27. If we combine them together and then we subtract them from one whole, just like you said, Ian, we would get an answer of 60. Is that what you got too?
Yeah.
Sweet. All right.
But I got 60%.
Exactly. Units are super important. Without a unit, we don't really know what we're talking about. Numbers have no meaning without units. If I told you I went to the park and I rode my scooter 3, how far was that?
I don't know.
Exactly.
Also, look at the left of your problem.
Ooh, hypothetical question. What if number 2 disappeared? I think someone is threatening to remove some of our problems. I think my old hacker is back.
What?
Sometimes in one of my algebra classes, I have a student who pretends he's a hacker and he tries to erase some of the problems. I think he's hacking me right now. I was kind of disappointed. Sorry?
That's my annotation, and I'm
not.
It's a hypothetical question.
So you're the hacker then?
I'm not a hacker.
Are you sure?
I'm using
Yeah, hackers can use annotations.
Yeah, but so can regular people.
Okay, touche. That's a good point. That's a really good point. Sorry, continue. What were you saying?
It's a hypothetical question. I'll start posting these during class.
Alrighty. Do you mean
If Deshana wants to do it, she can do it, but in some other color.
so? Do you mean if just the number 2 disappeared, or if the entire problem number 2 disappeared? I'm not clear on
No,
that.
like the number two disappeared, and all number 2s in the world disappeared.
Well, that would be very scary. We wouldn't have computers because there would be no binary code. We'd be stuck using probably base 9 because with base 10, we need 10 digits. We'd have to have base 9 if there's no 2, so we'd have no computer.
Hold up. You accidentally erased my question. So,
no, I answered it. I erased it on purpose, sir. Sir, I erased it on purpose because it's been answered.
Oh, so what were you answering?
I said if the number 2 disappeared, we would have no computers because computers use base 2 numbers. They use binary. And we would have only 9 digits instead of 10 in our base 10 system.
Why would we become base 9?
We'd have base 9 because there is no a 2 digit. We'd have only 9 digits instead of the 10 that we're used to. Instead of 0 through 9, we would have all of those except we'd be missing 2. So we'd only have 9 digits.
Oh, and
you asked really questions.
You forgot one thing.
What did I forget?
Date would look weird. Today's date would look weird.
I didn't even think about that. That's a really good point.
It would look like 0/8/1.
But with the number 2, we wouldn't even have a date. We would have no Gregorian calendar. Pope Gregory wouldn't even create the calendar the way we know it without the number 2. So things would be completely unrecognizable. But I think we should get started on 3. So it is
wait, can I do this? I call 3 all the way to 5.
All right, you got it. Let's see how you do 3.
Hold up. I'll color ones that are supposed to be mine in what? Green? Okay, so I'll color my problems in green and Deshetta's problems in transparent red.
What if we're all colorblind? Then what are we supposed to do?
I'm not.
It's a hypothetical question. I didn't say you are. I'm saying hypothetically, what if we're colorblind? Then what do we do? You like hypothetical questions.
Then if anyone here is colorblind, then I should just change the color.
Yeah, let's just do number 3.
So I have this. So number 3.
All right, show me how to do number 3.
So the green problems, the transparent green problems are mine. Transparent red problems are Deshetta's.
Great. So show me how to do number 3.
Number 3?
Yes.
Well, and I'll annotate everything else in blue. So I'll use all other
annotations. Let's not worry about the annotations. Let's not spend too much time on that. Let's try to get the problem done as fast.
Okay, I'll use black line.
We don't have that much time.
So 2016 is equal to 12 multiplied by x. What is x? Go find it. Calculator, whatever. I don't care how you find it.
You could divide by 2 twice. You would get 504, and then 504.
No. I said 12.
Yeah, I know. So you can divide by 12 by dividing by 2 twice, and then dividing by 3. That's how you do it mentally.
My only question was, what is x?
I don't know. You were going to tell us what it is.
I didn't ask you any shenanigans.
Well, the shenanigans are here to stay. There's always going to be shenanigans.
I asked you, what is x?
And I am waiting for your answer. I want you to show us how to do this one. I'm not going to give you the answer.
Well, I don't remember the calculation I got, but what I do remember is essential information. It's a whole number.
Indeed it is. But what number is it exactly? See if you can find that out. It It is pretty important. So while he's working on that, I encourage you to try it too, Deshetta. I encourage you both to try this.
I have to fix something. Okay, there, I fixed it. Okay, so what were you saying?
I was just telling Deshetta that I encourage both of you to try this and see if you get the same answer.
So the answer was 168. I just found that out. So x is 168. So since that's a whole number, we can pretend like the 2016 hours part is not there.
All right.
So I just added 12 plus 20 plus 16. Pretty smart, right?
Yeah, I would say.
And got 48 as the answer.
That is correct.
Okay, the second green problem is shooting hoops for 15 minutes, burnt 75 calories, blah, blah, blah. I just multiplied. So actually, I'll delete the screen. I'm not going to annotate for who's doing who from now on. That way. So I'm going to color code pieces of information since that's how I like to solve some problems. So shooting for 15 minutes burns 75 calories. How many calories would Carrie burn shooting hoops if she shot hoops 45 minutes every day for 1 month in February 2016? So you see those colored pieces of information, blue, red, green, and orange? I'm going to use them now. So I took 75 calories and divided that by 15 minutes because so that I can get how many calories burnt per minute. Then I can as per the green information, I can multiply that by 45. But what to do with the orange? What to do? Justin, are you there?
Yes, I am.
Okay, good. What do we do with the orange piece of information?
Good question. What do you think?
I multiply it by 28, since there are 28 days in February.
29, because it's 2016.
I was about to point that out. It is 20. I think you meant 29.
29.
29. So for some reason, it won't let me erase a 0. Never mind. For some reason, the thing really likes zeros. So I got this. So red divided by blue gives me 3. So 3 times green, 3 times 45 is equal to 90 plus 15. What is that? No, 135, yeah. And is anyone going to tell me what 135 times
75 divided by 15.
times 20 Deshetta equals?
So they're right. 75 divided by 15 is 5, not 3.
Wait, 5?
Yeah, 45 divided by 15 is 3, but 75 divided by 15 is 5.
Whoopsies. Haha. Thanks for pointing that out. But now,
You should think the
20, 25, 200 plus 25 is 225. So is anyone going to tell me what? 225 times 29 equals.
You could probably do it in your head by doing 30 times 225 minus 225, but I'm sure if you just did.
Wait, I was thinking maybe I could do 30 times 225 minus 225.
Yeah, that's exactly what I just said.
Good idea. So
yeah, that way you'll be able to do it mentally.
3 times 225 is 15. So 675. And then add a 0 to it. Subtract 225 and get, voila, 6525.
Fantastic. That is correct.
Okay. So,
number 5.
For number 5, I get confused. So, hold up. Let me draw some colored lines to show you. Red. So I got the red line. And I got the blue line. So I just gave you a spoiler that is half. That the answer to the division problem is something 0.5. But good thing I didn't tell you what the something is. But do we do the red length or the blue length?
So the ant is pulling along the edge of a regular hexagon. So this line right here, that's not an edge. The ant can't go through it. He can only go around. He goes clockwise.
Oh, so it's just the blue line?
Yep, he can't go inside the shape.
Oh, because I calculated the blue length. I wanted to ask him if it was the red length or the blue length.
It has to be blue. So let's figure out.
So you can't just. I already did all the handiwork by dividing it for you. You just need to calculate the sum of the blue sides.
Yeah, you're right.
Oh, you can't see which sides are blue. I see it now. There, you see it more clearly now?
Yes.
Now, can you add those sides?
So, if he goes all the way around, if he starts at A and then goes all the way around to A, that would be 100.
No, I already did that handiwork. The remainder makes you halfway around it.
So we have to figure out how many times 192 can go into 216 evenly, and then see if there is a remainder. Yeah, there is going to be a remainder for sure. So just do the division.
There is a remainder, but I did that and found out that it's some whole number, 0.5. I even remember which whole number it is. No need to do long division.
No, you don't think so?
I already did all that stuff, and I got 10.5.
Well, you're not supposed to get a decimal. You're supposed to just take the remainder instead.
Yeah, but I got it, used the decimal, multiplied it by the parameter, and that's what I got.
All right, so what did you get for your final answer?
So, you see the perimeter of the whole hexagon, the perimeter is 32.
32 times 6.
32 times 6, yes?
192.
192. So, 192. And then I have a red number. I'm going to make the red number the number they asked for in the problem, which is 216. I'm just going to be lazy and not draw the fraction line. But please remember that this is a fraction. So I calculated that. I'm going to skip how I calculated it. But I calculated, whoops, I wanted to color that in a different color. So I got it. So I got 10.5. And there's a reason I colored this 0.5 green. You know the reason? It's because I take this green part. I take the green part and multiply it by the parameter, which is the blue number.
Ah, so there is a method to your madness.
Oh, and also to write it in proper decimal form, you need to put a 0 here. Boom! They still represent the same value.
Indeed, they do.
The green part of the 10.5 represents the same number as the green number. The same thing as the green number in the multiplication problem.
True. So your final answer is just 0.5 times 192?
That's not my final answer. You have to do the multiplication.
All right.
I thought you'd do that yourself.
Well, if you do that, you get 96, and that's not correct.
96.
Wait, no, you get 86.
No, you get 96.
Oh, you do get 96.
Yeah, it's 96.
No, I can't do math. Sorry.
So 96 isn't correct, though. We have to use it.
It's because it's the pink length you were talking about.
Yep. So then what do we do when we have 96?
Let me make this easier to see. Why are you labeling the points?
Because we want to know where the ant's going to be after he travels.
Oh, two can play that game.
All right.
Dum.
So it's a question about how many groups of 32 we can fit inside of 96, and the answer to that would be 3. So the ant would have to be at point, he would actually be at point D after that. He would do 1, 2, 3 groups of 33. He would be right there. So the distance from A to C would have to be, yeah, you got it. So what would be this length going from A to D?
That would be the diagonal. So hold up, let me make a new green length. No, not green. I already used that color. How about a cyan length?
Go for it.
So I made a new cyan length, and the cyan length was constructed. So I'm gonna name it.
You have quite a colorful vocabulary.
I'm gonna name it A. I'm gonna name the cyan length A.
Makes sense. Keep going.
And I am going to make an angle. The angle looks like that. Look familiar?
Yeah, but keep going.
Oh, find a figure in the middle of the Wait, is that angle also right? No, but we can make a. Now, if we knew what A is, we would know what R is. Or what was that you named it? Do you name it R or something else?
Oh, that's supposed to be an L, but you know what? There's actually a much easier way to do it. Do you want to see the faster way, the easier way?
And then you put another. I think you know where this is going.
Yeah, you're doing the hard way, man. There's a much easier way to do it.
But now I've got 2 Pythagorean triangles.
You don't even need the Pythagorean theorem for this. Here. I'll show you my method.
No, you can just clear everything off.
So it's a regular hexagon. So if this is a side length of 32, it can be cut up into equilateral triangles with lengths of 32. And I'm horrible at drawing. I'm going to try that again because that.
Wait, can I draw for you?
Yes, go for it.
Only if you'll let me
Here,
use that. Yeah.
I'll draw one of them. We can cut it up into 6 equilateral triangles. All of them have a side length of 32. So
I'm
if
gonna use cyan. I'm gonna use cyan lengths for the one we want to find.
all right, looks good.
That cyan length is what you want to find.
Exactly. So 64 is the distance remaining. So this one has an answer of 64. We didn't even really need the Pythagorean theorem. All we need to do is a little bit of geometry knowledge, and then we get our answer much faster. 64.
Wait. You were describing the other things of the triangle you drew, not the cyan sides. Yeah.
How do you know that the 32 isn't pointing to the cyan? How do you know I'm not pointing right here and right there?
Okay, now you made it clear.
Yeah, I'm labeling the cyan, dude. You're assuming that I'm labeling the wrong thing, but I'm not. All right. So, does anyone want to do number 6? Do we have any interest who wants to do 6, or should I just do it?
You can do it.
Deshetta, do you want to do it, or do you want me to do it?
Sure. Okay. So the way I solve this one, so it's 4 times the product of. Yeah. Okay. So so first I just divided 2006 times 4 by 4. So I got 504. So then find the consecutive things, to find the consecutive integers. Shiny, stop! To find the consecutive integers, the Shiny apple! No apple! Okay, so I wrote the 3 consecutive, I just looked at consecutive numbers and found, and I 1, 2, 3, 2, 3. I didn't include 0 and stuff because I wanted to find the consecutive numbers that would get a unit digit of 4. So yeah. So then for that, I think I don't remember which ones I got. I do not remember which ones I got, but I wrote it down somewhere. They were. Remember which ones they were, but yeah, I know. I don't remember which ones they were, but I remember there was 2 options. There was only 2 options. It was 7, 8, 9, and something else.
Exactly.
So and then for the first thing, I did the 3 numbers without any tens digit, and then it was too low, and then I did it with a 10 added to them and the tens digit and stuff. So then that was too high, so then I did try to 7, 8, 9, and then that got 504. So yeah.
So we have 7, we have 8, and then 9. Oh, and then they just want us to find the sum of them. So that would just be 7 plus 8 plus 9, so we get 24.
Yeah.
All right, Deshetta, the floor is yours for number 7. You wanted to help us out with this one?
Okay. So, so I got 96. Okay, because the ratio of the number of dollars Alex has to the number of dollars Bob has is 34. So after Alex gives 40 to Bob, the ratio is 1 becomes dollars Bob is 1 to 3. So $100 to okay. So for 3 to 4, there's 7 parts, and for 1 to 3, there's 4 parts. So you can just make those ratios have the same amount of parts. So 3 to 4 becomes 12 to 16. Yeah, and then 1 to 3 becomes 7 to 21. So if 40, since it goes from 12 to 7 on Alex's side, that means, and 12 minus 7 is 5, then the 40 Alex gives Bob is 5 parts. So that means 1 part in this ratio. If it's all 28 parts, there is $8. So if Alex has, in the first ratio, if Alex has 12, if the ratio for Alex to Bob is 12 to 16, then and if there's in each part is 8, then that means 8 times 12 is 96. So that means Alex has $96 at first.
Very nice. I like that explanation. All right, $96. All right, on to the next one. Who wants to try 8?
I would like to solve 11 and I would like to solve 9, 11, and 12. Sorry. I wanted to solve 12, 9, 12, and 11.
All right. Do you want to do 8 too?
No, I was baffled on that one.
All right. What about you, Deshetha? Do you want to try 8? It is kind of tricky.
Where's Deshetha from?
Sorry, what did you say, Deshetha?
I tried.
Where's Deshetha from? I've always wanted to know.
But I live right here.
No. What's your origin like?
India.
Oh, really? Me too. Except
Me
you
too.
never.
I'm just kidding, not me. You can tell by my last name that I come from Poland. My name ends in the ski, so that's a Polish name. So let's do number 8. So let's take a look at the information. The escalator.
I already knew that from Polskanaki memes.
Indeed. So the escalator moves at a constant speed. Alex walks up the escalator at a rate of 120 steps per minute. So he's going to be going at the escalator speed plus 120. So we don't know what the escalator.
Let's call it X. I don't know, but I do want to call it X.
Always a great place to start. So the total would be X plus 120 because he's adding to the speed by walking at this many steps per minute. And then they tell us he reaches the top in 30 seconds. If he walks up the escalator at a rate of 80 steps per minute, he reaches the top in 40 seconds. So we want to multiply this by, what would be good? So we have distance equals rate times time. So 30 seconds, that would be, 30 seconds. That would be 30 seconds over 60 seconds because that's a minute. And then we're going to set that equal to, this time it'll be 80 plus X because he's going to be going up at a rate of 80 steps per minute. That looks like a weird 0. I'm going to redraw that. So we're going to have 80 plus X.
Sometimes I get confused, sometimes I look at 4s and think they're Ys. Sometimes I look at 4s and think they're 6s. Sometimes I look at 0s and think they're O's, and so on.
Yeah, sometimes when I draw a Z, it looks like a 2. So I have to be really careful to make it look like a Z. Like I do the little thing right.
I have a distinguishing mark on my 7s. That 1 tells it apart from all the other 7s, and 2, it helps it distinguish from an upside down L.
Exactly. This could actually be a Greek letter too. This looks like Greek letter gamma. So when you get into the Greek letters, things become even more confusing than before. So let's get back to the problem. So we have 80 plus X. That's going to be the new rate, accounting for his speed plus the escalator speed. And then this would be times 40 over 60 because that would be 40 seconds over a minute. So that's 40 seconds over 60 seconds. And then we want to solve for X. So we can start by multiplying both sides by 60, yoink and yoink. Both 60s go away. And then we're going to divide both sides by 10. So this goes yoink and yoink. So we have 3 times X.
You know there's a proof in math when you can make 20s disappear?
I don't know about that proof, but I'm sure there is something like that out there somewhere.
Yeah, there is a such proof, and Mr. Corbin taught it to me. A proof which makes 20s disappear.
I don't want to make 20s disappear. I don't have very many in my wallet. I'd rather hold on to the ones I have. So
No, I'm talking about number 20.
I know I'm being silly, okay? I'm trying to be funny, and clearly it's not working. Excuse me for that. So we're going to distribute the 3. We get 3x equals plus 360 equals 320 plus 4x. And then we can subtract both sides by 320. So we get 3x plus 40 equals 4x. And we get x is equal to 40. But then we're not done yet. I think this is just the escalator speed. So
yeah, I thought x was the escalator speed.
X is the escalator speed, but they're asking how many steps the escalator has. So how do we use this information to find how many steps it has if we're going at a rate of 40 steps per minute?
Let's call that S for steps.
Sure. What do we do after we have that? Well, we could plug it into either.
We're supposed to find S.
Exactly.
Not X. I think it's just the first variable that was mentioned. That's why I thought we needed to find it and therefore named it X.
So you could either use this equation, this part of the equation, or this part. It doesn't really matter. We would get the same thing. So just plug in what we get for x. If you plug x in for either of these, we would get 80 as our answer. So there are 80 steps in the escalator. All right, you wanted to do 9. Show us how to do 9. You have the floor.
So, I just need a minute to do something. Yeah, I need to find the radius of a circle. Oh, there, found it. I had to do calculations with numbers to find that radius.
Sounds wild.
Like if you're given, let's say, the diameter or circumference, you have to use calculations to get the radius. Okay, good, got it. So 9. So I used. So this is my technique, and you might have a different opinion on what to use, but just look at this and see what you think. Now, I have a Venn diagram.
Always a great place to start.
So I have a blue circle and a red circle, which are typical colors I use for making Venn diagrams.
Sure.
So this blue circle will represent pencils. The blue circle represents pencils, and red means pens. That weird purplish area means both, and the box outside both circles means neither.
Okay.
So that means that we have 7 of the boxes contain pencils. The 7 are in the. I like to start with either the overlap or neither. So neither we don't know, so X. And then 4 contain both. In red, in the remaining parts of red, there's just 1. And in the remaining parts of blue, there are just 2. No, not 2. I'm subtracting 7. So there are 3. So that's my Venn diagram. And all the numbers, sum of all the numbers equal 10. So 8 plus x must equal 10. So
You are correct.
8 plus x, the area inside the circles, plus the area outside the circles must equal the whole Venn diagram. So, and then if you learned anything in like basic algebra class, you had -8 minus 8, then x is equal to 2.
Well done and well explained.
So,
And if I remember correctly, you also wanted to do 10 for us?
I didn't say 10, I said 11 and 12.
All right. Deshita, do you want to do 10?
Sure.
Have that.
No ante quiet and dale. Okay. So, I just. No more.
Don't remember?
Okay. Anyways, no, I do remember. I'm just telling my parents to be quiet. Okay. Anyways, so I just wrote it. I wrote, how dimes are 10 and nickels are 5 and pennies are 1. So I just wrote DDD plus N and then DDD plus. I just wrote the stuff, but with the letters saying them. So yeah, I just wrote all that stuff, and I got 19 combinations.
All right. So what did you get for your answer?
I think she's on mute and telling that guy to be quiet.
Oh, okay.
No. I said I have 19 combinations because I wrote out the combinations with the variables for each.
So you are one combination short. There should actually be 20.
Okay.
There should be, I think, 2 combinations that have 3 dimes, 4 that have 2 dimes, 6 that have 1 dime, and I think 8 that have no dimes. So that would give us a total of
Everything using, I tried to add everything by identifying what
I got the 6th one that had 1 dime.
Oh, that makes sense. Okay. By all means, if you need to go yell at somebody, go right ahead. I don't want to interfere with that. I don't want to interfere. So we have 20 for this one. There are 20 possible combinations that add up to a total of 35 cents. All righty. So it is your turn, Ion. You have the floor. I called you Ion instead of Ion. Ion is like a chemistry thing. What am I thinking? All right, Ion, you have the floor.
I think you used to study chemistry back at a younger age and don't remember it.
I do remember it, but not as much as I'd like to. I remember ions. I remember some stuff from chemistry. I'm supposed to be teaching it, but no one signed up yet.
Oh, 0. Do you mean like 0 people signed up or very few people?
0.
Oh. Okay, so I said I wanted to do so I just got some pencil and paper and I just worked it. I just worked it out and got this. Look familiar? The answer is that the year that this AMC thing was made.
Oh, really?
Yeah. It's 2016. It's 2016. Looks at calendar. Never mind.
I got
The
some.
answer is 2016. I just put it there because.
Not quite.
But why? No. But why did you say when I asked that hypothetical question that why did you say that Gregorian wouldn't have invented a calendar if it weren't for the number 2?
That's a good question, but we're running out of time. We don't want to waste too much time on hypotheticals. The answer for 11 is actually 1009. Do you want to try it again, or do you want me to show you?
You can show me.
All right. So how many terms are there from 1 to 2015?
I think I calculated that wrong.
Try that again. Like, the thing about math is if you make a little mistake, you get complete wrong. You get the complete wrong answer, and it's hard to tell if you're really close or if you're really far away. So I encourage you to try it again, because that's going to happen constantly in math, especially when you take calculus and differential equations and linear algebra. That's going to happen constantly. So it's good to have perseverance. Keep trying it again and again until you get your answer.
Ask some teacher to tell you whether it's wrong, right or wrong. How do you know when it's right or wrong?
Well, that's a good question. Sometimes you'll have enough information about the subject to tell if it's right or wrong. Like sometimes you can tell that, hey, it clearly can't be that. It obviously can't be a million. In some cases you can tell, but
yeah, like if you have 2 plus 2 minus 2 and you find out that it's undefined. Last time I tried to calculate 20,000 times 2 times 0 on a calculator, and it said undefined. I don't know if that's a calculator error or my internet's really bad.
To me, it sounds like you accidentally divided by 0 instead of multiplying.
Oh, I think I accidentally put the division sign instead of multiplication sign.
You can't divide by 0, and you'll find out why when you take calculus.
Why can't you? But why can you divide 0 by 20,000 and not do 20,000 divided by 0?
You'll find out when you take calculus why that is. So, Deshetta, how about you try this one for us? You said you have some ideas. Go for it. I think she has to go yell at someone again.
I don't have any brother or sister. That's why I don't go for such things.
I don't have any living with me, but sometimes you just need to yell. Sometimes you need a good yell.
Okay. Oh, wait. What did you say?
We're doing 11. So you said you had some ideas about how we could possibly do 11. So
okay. Yeah. So basically, how I did this was so there's the last one. The last 2 numbers are like 2015 plus 2000. I don't know why I felt like I need to do like ignore the one. Like we don't ignore the one. We just do the one with less mine. I wanted to start 1 minus the 3, and then you get a -2, and then like okay. So I just did like the first few things. I did the first few addition things, like the -2. So then it goes like -2, 3, -4, -6. So after on the after like on the 5 and the 9 and the 13 and each thing after the addition symbol, because 2017 is after the addition symbol, they're all like the next on number. So yeah, so they're all the next on number. So since there's 2000 okay, so yeah, okay, so yeah, I don't remember. Wait, I need to for a second. Okay, so there's like okay, so there's 2007. Okay, so yeah, there's basically like the amount of numbers in this pattern thing is 2017 divided by 2 plus 1, I think. So that gets like no, yeah, no, sorry, what? Okay, divided by 2, but like rounds up. Yeah, so 2017. I think that was it. I don't remember. Okay, so there's yeah, so that 1008.5 round up, you get 1009 because there's also that one thing. So 1009, there's 1009 numbers in there, and there's like and every plus every after each addition sign, the odd numbers go up, but there's like after like the one there's like two numbers each going each there's two numbers for each there's like every um ignoring the one, every second number is where the odd number thing falls, the odd number answer falls. So then so
I'm
that
pretty sure the answer was
1000
odd. I don't know how I ended up with what I ended up with.
1000 okay, so there's the three okay, so there yeah, every the 5 and the 5 and the 9 and okay. So then this where the so you get 1 minus 3, 0, negative 2, and then 3. So yeah, it just negative 2, 3, negative 4, 5, and then and the whole thing. I'm pretty sure there's like 1009 numbers, and every addition symbol there is every addition symbol. So after the addition symbol, that's where there's always a positive odd number. So after each addition symbol. So 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 we can just if we just pretend the one isn't there for like 2 seconds. So I guess like not like with so like there's um the one there's no the yeah there's no there, so it's like not it's because that one is not part of the addition stuff and yeah so then there would be 1008 numbers. You divide that by 2, and then you get 504. And then so if you have 504, every like you had a sequence that was like every odd number, and it started on 3. Yeah, 3. Okay, if it started on 3 and there's 504 numbers, pretty sure you get 1009. Or if you had 505 numbers and it started on 1 because 1 is the first number in the entire sequence, and it would also be 1009. Yeah. I don't know how to explain that, but that's how I got it.
So I heard a few different methods there, and I agree with the one where you got the value of 1009. So this was pretty tricky, that the total value would be 1009 here, and time is just flying by way too fast. If you guys want, we could probably talk about it in depth at the next session, but I feel like we want to cover as many of these as we can in the remaining 5 minutes or so. So I want to ask you guys if you have any questions about 12. If not, we'll just keep going. So let's not spend time on problems if you guys don't have questions on them. So what do you guys think about number 12? Do you want to cover that, or do you want to keep going?
I don't have question on to in that.
All right. What about 13?
I think I know the they use different units to try and trick us, by the way.
All right, but did you get it?
Yeah.
All right, what about 14?
No questions.
All right, what about 15?
Wait, why did you skip 13?
I asked if you guys had questions on 13 and you said no.
Oh, you asked if we had questions on 12.
And then I asked about 13. I asked about both of them. So do you have questions about 13?
No, I was just asking why you skipped it.
I didn't skip it. I did say 13. What about, you said no for 14. What about 15?
Or 15?
No, I have no question.
You have a question on 15?
No.
No. I think I have a question on 17.
All right.
I don't know how, like, is there an easy way to calculate such numbers?
With 12 factors. So you would have to use a factor tree. And there would be a way to create a pattern that would allow you to find all of the numbers that have 12 factors, all the 2-digit numbers. So we want to maybe identify the 2-digit numbers that might work. So the lowest of all of them would be 11, or sorry, 10 actually. And then the highest of all of them would be 99.
Actually, you forgot 10.
I wrote 10 right there.
I don't think zeros are allowed.
Is 10 a 2-digit integer?
Yeah.
Yeah, so 10 is allowed. It may not work, but it is definitely a 2-digit integer, and we should definitely consider it.
So, if it's a 2-digit integer, why did you say from 11?
So I said that by mistake, and then I correct myself, said, oh, I meant to say 10.
And you forgot someone named 100 too.
Well, 100 has 3 digits, though, not 2.
You are just on a streak of forgetting powers of 10. First 10, then 100.
No, I intentionally left out 100 because they're only asking for 2-digit numbers, and 100 has 3 digits, so we're not going to include 100.
Oh, well, what if it satisfies your other condition?
Well, we're still not going to include it because they only ask for 2-digit numbers.
Okay, sounds reasonable.
All right, so let's talk about the factors of 99. So 10 is not going to work. It definitely doesn't have 12 factors.
Wait, any number that's greater than, let's try numbers that are greater than 12 because 12 is the number specified.
All right. Well, 12 doesn't have 12 factors though, or does it?
All numbers that are strictly greater than 12.
So 12 only has 6 factors. So we're definitely not going to include any of the prime numbers. We're probably only going to include numbers like maybe 30, 60, 90 that we know for a fact have a lot of factors. But actually,
hey, what about, hold on, let me think of a number that has a bunch of factors. 36?
it could possibly work, but unfortunately we are all out of time for this evening. I hope you had as much fun with this as I did. Hope you guys have a great week, and I'll see you next time.
Wait, really?
Yeah, it's already 7. And I have to do another class after this, so see you.
Also, I got student of the week.
Oh, congratulations. Very nice. All right, have a great week, you guys.